some regression models, just for the sake of example. I might be interested in seeing if condition interacts with whether the participant has ever had depression or not, to predict the belief that most people support discrimination. So here I'm fitting a regression model that tests exactly that. With the response variable, most support discrimination, the tilde is separating it from the predictors, and then two predictors with an asterisk between them indicating that I want the interaction and all of the necessary lower order terms in order to make the interaction term sensible. That's all fed into the LM function, which is fed into the summary function. And here, the interaction term is small and is not statistically significant. In fact, all of these are small and not statistically significant. But just an illustration of how I might fit a regression model for this data set. Here are some more like that. This is the moderator that we actually predicted, the sort of generalized trust in the judicial system that participants reported. That's this trust courts variable. So we thought that being told that discrimination is legal might have a bigger effect on people if they trust the courts generally. And so here, if I run this regression model, testing whether most support discrim is predicted by the interaction between condition and trust courts, I get a weak interaction. And I also see similar interactions for the I support discrim variable, the evaluation of Amy, the character in the scenario, and the general evaluation of people with depression and people with mental illnesses generally. So I might be interested, for example, in estimating the effect of the condition, the manipulation, at low, medium, and high levels of trust in the judicial system. There's lots of ways of defining low, medium, and high for this purpose. They're arbitrary in this case. I don't have any real benchmarks for that, so I'm just going to use one standard deviation above and below the mean. It doesn't really matter that much what I choose here because this effect is constrained to be linear, so my estimate of the condition effect will change linearly across the entire spectrum of trust in the courts, and it's up to me to decide whether estimating it at a particular point along the range of values of trust in the courts is sensible or not. So here is that estimate at one standard deviation below the mean. This is an R workshop and not an interaction test workshop, but just as a quick refresher here, I'm fitting exactly the same regression model, right? It's most support discrimination is the response variable, and there are two predictors separated by an asterisk representing exactly the same interaction. But I have rescaled the trust courts variable here. Scale is a function that is built into R. I'm pretty sure. There it is, base. So yeah, I've been previously when I wanted to see where a function came from in terms of packages, I was looking at the help pages, which is one good way to do it. You can look up in the upper left corner. But also you can just do this and see that this comes from the base namespace. Scale just z-scores it by default. So I'm using it for that purpose here. So I've z-trust in the courts and then added 1 to the z-score. So now the result is a vector of values that has its 0 point at 1 standard deviation below the mean. So this is a version of the trust in courts variable that is coded so that 0 falls at 1 standard deviation below the mean. I've enclosed the entire thing in this I function, just because I don't need to in this case, but it's a habit. Anytime I do arithmetic on variables that are included in formulas, I tend to just include them in the I function in order to make sure that I'm not accidentally communicating something that R will interpret as being part of the formula for the statistical test that I'm trying to carry out, rather than part of the arithmetic for the transformation of trust in the courts that I'm doing on the fly while calling this LM function. You could, of course, rescale trust in the courts before calling LM. I'm just doing this all in one step because I sometimes find that convenient. So this version of the model has exactly the same interaction that we saw before. This part of the output will not depend on what I did. But trust in the courts is set up so that its 0 point falls at 1 standard deviation below the mean. And so the cond legal variable here, cond is the name of the variable. Whoops. Legal is the name of the level that's coded as 1 automatically in this version of the regression model, which happened because cond is a factor in the way R is currently treating it. This row of the output represents the effect of the condition variable estimated at the point where trust in the courts is 1 standard deviation below the mean. And it is positive, that is, the legal condition had a slightly higher estimated value than the illegal condition, but not statistically significant. Here's the same thing estimated at the mean of trust in the courts. So this version is set up so that trust in the courts has its 0 point at its mean. And here, the condition effect is bigger and statistically significant. And at 1 standard deviation above the mean, it is bigger still, which of course it's constrained to be. These 3 points are going to form a line because that's the constraint that I'm applying with this linear model right now. Talk to me later if you have questions about what exactly that means. But one way that I can interpret this is that the effective condition seems to be bigger for people who trust the courts more, generally speaking, on this inference that most other people support discrimination. I could look at similar kinds of ways of partitioning, of exploring these other interactions. So for I support discrimination, the variable indicating that the participant answered a bunch of questions consistent with supporting discrimination on the basis of depression or mental illness history. At 1 standard deviation below the mean of trusting the courts, the legal condition seems to be associated with slightly higher values of supporting depression or discrimination, but not statistically significantly. And it's a bigger effect at the mean of trust courts and bigger still at 1 standard deviation above the mean. So similar kind of interpretation as the inference that most people support discrimination. The evaluation of Amy is more favorable in the condition where discrimination is legal for people who don't trust the courts much. About the same regardless of condition for people who trust the courts an average amount, and seems to be somewhat more negative in the condition where discrimination is legal for people who trust the courts a lot, but that's not statistically significant. So something a little bit different is happening with this evaluation of Amy variable. And I'm not, doing this workshop to talk about this particular data set, so I'm not going to go into details about why I think that might be the case. And you could do the same thing for the evaluation of people with depression and mental illnesses generally. Seems to be more favorable in the legal condition for people who don't trust the courts. Like they have sympathy in the case where the person lost the lawsuit. But in the case where people do habitually trust the courts, the sign here is flipped, and by some interpretations, this would be statistically significant, suggesting that people who habitually trust the courts seem to report more negative attitudes on the basis of mental illness history when they think discrimination on that basis is legal. Okay, and then one quick example of a plot before I open the more detailed plotting demonstration. I guess this is a fairly simple example. I'm going to set up a couple things ahead of time. The first thing is some colors that I'm going to use. I'm going to use blue and red. This is just one way of setting up colors, not the only way, but I'm going to take the color blue, or the name blue, the string blue, which R will interpret as representing a color when I supply it as an argument, as the color argument to a plotting function call. And I'm going to repeat it as many times as the length of the condition variable, which is the height of the data set. So currently useCall is just blue repeated over and over again, but then I'm going to change the ones where condition is illegal to red. So now useCall is blue in the legal condition and red in the illegal condition. And then I'm going to plot the evaluation of people with depression and mental illnesses generally against trust in the courts using this color. So each point will be represented as blue if they're in the legal condition and red if they're in the illegal condition. And I'm going to use this plotting character, number 20, which just happens to be a nice little circle. So here is that plot, in case you wanted to have a scatter plot that's color-coded by condition. I might also, for example, add some lines to this scatter plot. So this one will add a line that's colored blue, representing the subset of the data for which the condition is legal, the relationship between the evaluation and the trust in the courts variable. And here's the same one in red for the illegal condition. So these are the lines that fit those points. This is an illustration of one of the interactions that I just talked about a second ago from the regression models. Careful using this strategy to plot stuff. This works in this case. I'm using subset here, and that only works because in this case I set it up so that I know that these subsets are equivalent to the simple effects that I'm actually interested in. But be sure you know what you're doing before plotting things this way.